Okay. Good morning. In today's class, we'll discuss elementary signals. Many times they are referred as singularity functions. Singularity functions are the functions or the signals which can be derived from one another. That means if x of t is given, then I can derive y of t by a process of, or by some mathematical process called as derivative or integration. So by making use of these mathematical tools, I can get y of t from x of t. Then these functions are called as singular functions. Okay, so basically elementary signals are singularity functions. We'll discuss these signals one by one. These are the basic signals which are very often we need while constructing various types of signals. So very first basic signal is a basic elementary signal is a unit step signal. Unit step. Why it is called a unit step? The reason behind is that its amplitude or its magnitude is always equal to 1. Its amplitude or magnitude is always equal to 1. So how it mathematically looks? So if we draw this signal u of t, it is denoted by symbol u of t, and when we plot this signal with respect to t, we get the nature of signal something like this. Its amplitude is equal to 1 at t is equal to 0, and it remains 1 forever till infinity. This goes to the infinity. So this is a unit step function. So if we want to describe this signal mathematically, it can be described that its amplitude is equal to 1 for t greater than or is equal to 0, and it is equal to 0 for t less than 0. So this is a mathematical definition of a unit step. Then immediately we'll go to the next type of a signal. Second type of a signal is called as a ramp function. It is also sometimes called as unit ramp. Now why it is called as unit ramp, we'll discuss within a while. So it can be shown like this. R of t, if we plot with respect to t, then it is something like a straight line passing through origin. So this is what a ramp function looks like, and mathematically it can be defined like this. R of t is equal to t for t greater than or is equal to 0, and it is equal to 0 for t less than 0. So this is what unit ramp. And why it is called unit? Because at any point of time, if you calculate the slope, then the slope of the line will be equal to 1, and the slope of the line is equal to 1. That's why it is called as unit ramp signal. So this is one of the important elementary signal, unit ramp. Now let us discuss the relationship between unit ramp and unit step. I know that this is my ramp signal, this is my R of t signal, and its slope is everywhere, its slope is equal to 1. That's why we call it as unit ramp. So this is t is equal to 0, and mathematically we know that it is defined at it is equal to t for t greater than or is equal to 0, and it is 0 otherwise. So this is the definition. So if we are interested to find out the derivative, so if we want to plot dRt by dt, then we know that derivative is nothing but a slope. Actually it is a dy by dx. This is nothing but a slope. So when we take a derivative is also nothing but a slope. So the slope of this line is equal to 1. So when we are interested in plotting dRt by dt with respect to t, we get a slope constant which is 1. So we get a constant line here, and therefore very important conclusion we can draw and that is u of t is derived from dRt by dt. That means when we take the derivative of a ramp signal, then we get a unit step signal. This is a very important conclusion we draw. And as we have already said at the beginning of our lecture, that singularity functions are those functions which can be derived from one another by making use of mathematical tools, mathematical functions such as the derivative and integration, and this is very clearly we can see here. And therefore u of t and r of t are singularity functions. So this is a very important relations, important conclusion we can draw from this. Similarly, from this relation, if we want to obtain r of t in the form of u of t, then we can get this relation as u of t dt integration, okay, from obviously minus infinity up till t. So this type of a definition we always came across while solving numerical problems in signals and systems. So this is what important relationship that we have derived in case of unit step and unit ramp. The next important signal we will be going to study is unit impulse signal. Now we know that suppose this is our ramp signal and this is certain signal x of t given to you or given to us, okay. This is, let's say, at t is equal to, at let's say 1, its value will be equal to 1, okay. Now suppose if we take the derivative, of this signal dxt by dt, then we found that here the slope of line is 1, because here we move on the x-axis from 0 to 1, so this amplitude is 1, and in the same time my amplitude will change from 0 to 1, and therefore if we want to find the slope of this line, only this line 0 to 1, this instant line, if we want to find the slope, then the slope will be equal to 1. And as we know that the slope of the line is nothing but derivative, or it's a differentiation. So when we differentiate this portion, we'll get a constant. So we till this point we'll get amplitude is equal to 1. But now here onwards you observe from this 1 onwards the magnitude is remaining same, that is 1. So if we differentiate this, then it will become 0. So at this point it will go to 0 and then it will remain 0. Now very interesting fact we want to note here. If we reduce this t, that means if we increase, if we decrease the value of t, let's say t is equal to 0.5, then obviously this y value will be going to increase, okay. When this x denominator will be going to decrease, obviously this overall factor will be going to increase. If you observe, the area under this curve is equal to 1, area under this curve is equal to 1, but now if we decrease this, its magnitude will certainly increase, okay. And as we go on reducing this further, okay, we'll observe that this height will be going on increasing, and at particular interval of time when t tends to 0, the amplitude will tend to infinity, because when this factor denominator will going to be equal to 0, its amplitude will be going to equal to infinity. But infinity we cannot deal in mathematics, and therefore we can show this by just an arrow indicating its value is equal to 1. It doesn't mean that the amplitude of this signal is equal to 1, but it means that the area under the curve is equal to 1 for this particular signal, and it is denoted by signal function delta t, and this is also called as a direct delta function. This is very important function we come across but there is a problem while defining this function mathematically, and hence it is defined as area can be found out by making use of integration. So delta t dt, this value, if I integrate from, let's say, minus infinity to infinity, then the area under this curve is equal to 1. So this is the definition of impulse signal or direct delta function, and it is a very famous function we use many a times in signals and systems. So this is impulse function. Okay, in the next class we'll discuss the various operations on these signals, and we'll study the different properties as well. Thank you very much. You like the video, then you subscribe it. Thank you very much.